Okay, so this is 3.3. So we're going to describe the domain, the range, all the things. So find the local minimums. Now minimums are the lowest y values. So down here, that's a minimum. Oops, I should change color. Down here, this is a minimum. This is a minimum. Okay, so local minimums are going to be like 1 comma -6. That's right here. And -2 comma 3. Maximums are going to be the opposite. They're going to be up at the top. So anywhere that there's a dip or like a swoop up at the top, that's going to be a maximum. So that's going to be -4. I'm sorry, 1 comma. Let me try this again. -1 comma 4. Domain for these functions, it's from -infinity to +infinity. The range is going to go from the lowest number, which is -6, to the highest number, which both of these are arrows, so that's infinity. Intervals of increase and decrease. Okay, so intervals of increase, that means that the numbers are going up. Okay, so from here to here and from here to here. So we're looking at our x values. That's -2 to -1. And then from 1 to +infinity. For decrease, that's from here to here. So that's -infinity to -2. And then from -1 to 1. And then that's it. Okay. Over here, you've got local minimums here and here. Okay, and again, you'll list those out. Maximums, that's going to be this number up here. So we're going to say this is roughly 0.5. If you actually graph this on Desmos, you can see that point itself. But that maximum is in between those two numbers. So describe the domain. It's going to be the same as the last one, -infinity to +infinity. Range, the lowest y value is -8 to +infinity. Intervals of increase. This is increasing, this is increasing. So that's going to be from -1 to 0.5. And then from 2 to +infinity. Decrease is going to be -infinity to -1. And then from 0.5 to 2. Okay. Now, as x decreases, your y values are going up. So that's for +infinity. So as x goes to the left, it's going up. So that's +infinity. And I'm going to scroll it down so we can actually see the rest of this. As x increases, so as we're moving to the right, your y values are going up. So that's +infinity. Same thing for this one. Your x-intercepts are where it crosses the x-axis. So these are going to be 0, 0, and 1.5 comma 0. And then the y-intercept is 0, 0, because that's where it crosses the y-axis. Hopefully all of this is kind of like a little bit of a refresher from like algebra 2 or 1. And then the y-intercept is going to be 0, -3. Okay, now why does this matter? So when you start looking at stuff, you're looking at net worth and profit optimization. That's what all of these functions are going to deal with. So you've got to be able to read the key features that are going along with these. So company's net worth for the first 6 years after it opened can be modeled by this polynomial function, where t is the measure in years. Identify the domain and the range for the graph of this function. So if we're just looking at the graph, then the domain is always going to be the same for these, -infinity to +infinity. For range, it's also going to be -infinity to +infinity. We can take this equation and we can actually graph it in Desmos. Okay, so this is going to be a cubic function. This is something that you learned about in algebra 1, maybe 2, depending on when you took it. So we're going to take this and we're going to type it in. So x to the third minus 6x squared plus 8x. Okay, so it looks like this. So domain is -infinity to +infinity because it can be any value from left to right. And then range is from bottom to top. That can be any value. Okay. Let's go down. during what years did the company have a negative net worth? So we're looking at when was it below the x-axis? Well, we wouldn't look over here because that would be negative time. So between 2 and 4, it has a negative net worth. So we're going to say from 2 to 4. Okay, that's because it was below the x-axis. On number 4, many businesses know that the most consumers associate price with quality. If it costs more, it's going to be higher quality. Okay, an actuary at a cosmetics manufacturer determined that the profit made the price charged for a lipstick at a particular retail outlet could be modeled by this equation, where P is the price in dollars and V of P is the amount earned in the retail store selling by the lipstick in a month. How should the store charge to maximize its profit? So if you take this equation and you plug it into Desmos, which you will be able to do, notice how I'm turning these P's into X's, because if you try to type P into the calculator, it's not going to give you the graph. So when you type this in, okay, this is the graph that you get. Okay, and if you zoom out, we can see the graph a little bit better. You always want to kind of like get rid of the negative side because we're not going to have negative months. Okay, and we want to maximize our profit. So we're going to look at the highest value. That's right here. And what's the X value? X value is what we charged. That's 15.26. 15.26. So if the store charged 15.26, this is going to be where it can maximize its profit, can make the most money. So you always want to use Desmos on this. Okay, on the next one, same thing. So new hybrids, car fuel company, depends on how fast the car is moving in miles per hour. The following polynomial is reasonable, accurate from 20 miles per hour to 90 miles per hour. Here's the equation, where S is the speed in miles and F of S is the fuel economy in miles per gallon. What speeds between 20 and 90 would maximize fuel economy? So we're going to take our equation, we're going to write it out, and then we're going to plug it into Desmos. X to the fourth plus 0.0035 x to the third minus 0.23022 x squared plus 6.8832x minus 59.8. Okay, so we're going to go into Desmos, and we're going to type that in. So negative 234 2x to the fourth plus 0.0035x to the third minus 0.23022x squared plus 6.8832x minus 59.8. Okay. So when you look at this and you zoom out and look at the maximum, this is a little wonky because it's like quartic. So what would be the highest between those numbers? It's going to be roughly around sure, 4x to the fourth, 0, 3, 5, 6. This number. There we go. So it's going to be roughly 66.17. 66.17. Okay. So again, you're looking for the maximum amount after you type it in the calculator. So 66.17. You always want to round to about 2 decimal places just to make it a little bit easier. And that's it.